Hello everyone, this video is for standard 8. In the previous video for standard 8 we had solved the exercise 3c. Then this video we are going to solve the examples given for exercise 3d. Okay, so let's begin. Square root. What is square root? Let's say the definition first. Square root of a number is x. Number x is that the number that which when multiplied by itself gives x as a product. Square root of a number x is that number which when multiplied by itself gives x as the product. It means that if there is a number x, okay, whose square root is what, y, then it means that when y is multiplied by itself, that is when y is multiplied by y, it gives what, x. This is the definition of square root. Okay, when square root is a number, x is a number x, square root of a number x is that number which when multiplied by itself, square root of a number x is that number which when multiplied by itself gives x as the product. Okay, this is very simple. Let's see the examples. Square root of 4 is what, 2. So when square root of the 4 is 2, when 2 is multiplied by itself gives 4 as the product. This was only the definition of a square root, that square root of a number x is that number which when multiplied by itself gives x as the product. Okay, square root of 4 is a number which when multiplied by itself gives 4 as the product. That's it. In the same way, 9 square is 3, 16 square is 4, and this. Okay, let's come to the next. Square root of a 4-fold square by prime factorization method. This is very simple method. Okay, you just have to learn the divisibility rules which have been given to you previously. Okay, you have been given 2 to divisibility rule from 2 to 13. Okay, and they are going to be very helpful to you. Please learn that before solving this exercise or examples. Okay, chalo, a square root of a perfect square is by prime factorization. We have been when a number is given a when a given number is a perfect square, we find the square root by following steps. Resolve the number into prime factorization, make pairs of the similar factorization factors, take the product of the prime factorization by choosing one factor for every pair. This is very simple. Let's see the first example. The first number is the 324. We have to find the square root of it. Simply, as it is an even number and all the even numbers are divisible by 2, we can go for it. Okay, so when 2 divides 324, we get 162 as a quotient. When 162 is divided by 2, which is again in an even number, then it gives 81 as the quotient. Now 81, you must be familiar with the divisibility rule of 3, which says that when the sum of digits of a number is divisible by 3, then the number would be divisible by 3. It means that suppose if it is 81, when the digits of 81 are added, then the sum is what, 9, which is divisible by 3. So the divisibility rule that says that when the digits of a number is sum of digits of a number is divisible by 3, then the number is divisible by 3. Okay, following the same rule, you have to keep dividing until you get one or any prime number, okay, as the quotient. Okay, chalo, now by prime factorization we have gotten these prime numbers. Okay, and you know that you have to take the product of prime factors, choosing one factor out of every pair. Matlab, if there is a pair for 2, then you have to take one pair 1 2 out of it. If there is a pair of 3, you have to take 1 3 out. If there is a pair of 3 again, you have to take 1 3 out. In this way you have to find the product of all these three, which is 18. and 18 is the square root of 324. Now let's come to the next number. 730 is 764. You have to find the square root of it. This is also very simple. um, this is even number divisible by 2. Again 441 divisible by 3. And now 7's divisibility rule is also given. Although 49 is very simple number, you can um, simply subtract this. Yes, you can simply find k7 7 just 49. You must be knowing the table of 14 is 7. Now I am telling you the divisibility rule. As I have already given you the divisibility rule, but still I am telling you 49, the divisibility rule. Whether how we will decide whether it is divisible. Suppose someone doesn't know the table of 7 even. What he will do? He will uh, multiply the ones place digit by 2. Okay, in ones place, that is 9 into 2 is what? 18. And he has to find the difference of other numbers. Okay, leaving ones place other numbers and the twice of the ones place digit. The difference is what? Is minus 14 or 14. Anything minus is of no use. Okay, you can consider it to be 14, which is divisible by 7. So better learn the tables, okay, and divisibility rule as well, because after some time you will get the bigger numbers. Okay, so 7 by 7 the number is divisible, so you have to divide them by 7 and you have to get the prime factors. Make one out of each pair, uh, write one out of each pair, and then find the product. You have the square root. Now again the same other number has come in the same way. Now 1 to 1, the you have to go by you have to first consider the divisibility rule of 2, which is which says that all even numbers are divisible by 2. And then 3, then 11. 11 its divisibility rule is that if the difference of uh, sum of odd sum of alternate digits is divisible by 11, then the number is divisible. 0 or 11, just I'm telling you, the it might be confusing to you, but I'm telling you how. 1 to 1. Okay, 1 to 1, the alternate places are this. Okay, if the difference of sum of alternate numbers is either 0 or divisible or a multiple of 11, then the number is divisible by 11. Suppose 1 and 1 is what? 2, and when we subtract 2 from 2 we get 0. It means that it is divisible by 11. Okay, so in the same way you will get it. Okay, follow the same way, you will get 66 as the square root of the given number. Now next is to find the prime factorization. Same thing. Okay, now it is an odd number, and you know that the numbers that contain 0 or 5 at their ones place are divisible by 5. So following this rule, you have to use them and find the prime factorization by division method. Okay, and let's come to the, yeah, this is a bit different from others. In an auditorium, the number of rows is equal to the number of chairs in each row. If the capacity of auditorium is this, find the number of chairs in each row. Very simple. So you have to find the square root here. Let the number of chairs in each row be x, then the number of rows is this, then the number of chairs in the auditorium according to question only. See, number of rows is equal to the number of chairs in each row. So if the number of chairs would be x, then according to the question the number of chairs rows will also be equal to the number of chairs. Okay, and the total number means the product of the chairs and rows would be the capacity of the auditorium. So according to question, this is the capacity of the auditorium. So this must be equal to 2025. X square must be equal to 2025 by the question itself. So we find the prime factorization, and we get to know the number of chairs in each row or the number of rows, because both of them are equal according to the question. Now find the smallest number by which 396 must be multiplied so that the product becomes a perfect square. Okay, 396, chalo, we have found the prime factorization here, and after doing the prime factorization, we come to know that 11's pair is not available. Okay, so 11 should be added here, or you can say multiplied here, to make 396 a perfect square. Okay, so in order to it is clear that in order to get a perfect square, one more 11 is required, so the given number should be multiplied by 11 to get the to make the product perfect square. That's it. Next question, find the least square number divisible by 8, 9 and 10. This is also very easy. Okay, you have to just find the LCM of these numbers, that is 8, 9 and 10. Okay, the LCM of these numbers is what? 360. 360, but 360 is not a perfect square. Okay, so we have to make it perfect square. How we will make it a perfect square? We'll do the prime factorization of 360 and will have the numbers whose pairs is not available in this prime factorization, and those numbers whose pair is not available, they will be multiplied to make 360 a perfect square, and that would be the least square number divisible by 8, 9 and 10. So after doing the prime factorization, we come to know that 2 and 5's uh, pair are not available, so we need to multiply the given number, that is 360, by 5 into 2, which is 10. So this is the number. That's it for today, and now solve these questions properly. Thank you everyone.